Hello all, how are you? I hope you are all fine. Welcome to our science class. Today we are going to learn about a new and interesting chapter. Chapter number 15, Light and Associated Phenomena. It's there in your textbook. Open your textbook at page number 214. 214. So let us start the topic. Let us start the chapter by mind map. So the chapter is about light and associated phenomena. So what do you mean by light? It's a form of energy. Is it not? Yes. Light is a form of energy. So light always travels in a straight line. Light always travels in a straight line. So that is called as rectilinear propagation of light. Rectilinear propagation of light. Clear? Now we are going to learn about the things which is associated with light energy. So first about reflection. What is that? Reflection. What do you mean by reflection? Bouncing back of light from the surface. Bouncing back of light from the surface. That is said to be reflection. It is called as reflection. Then this reflection is of two types. That is regular reflection and irregular reflection. Then we are going to learn about plane mirror, curved mirror and all. Clear? So this is what about reflection. Next concept is about refraction. Refraction. Okay. So what do you mean by refraction? When ray of light passes from one transparent medium to another is said to be as refraction. Clear? So here both the medium will be of different densities. Clear? Yes. Next concept is about lens. We are going to learn about lens. What do you mean by lens? A transparent medium having one flat and one curved surface. Either one flat or one curved surface or both curved surface. Either one flat and one curved surface or both curved surface. Okay, I repeat. Next concept is about lens. Here lens is nothing but a transparent medium having one flat and one curved surface or both curved surface. Again, this lens is further classified into two types, that is convex lens and concave lens. Convex and concave. Remember kids, convex lens always it will be thick at the middle and thin at edges. Thick at middle and thin at edges. What is that? Convex lens. Next thing is about concave lens. Concave. So what do you mean by concave? Thin at the middle and thick at the edges. Thin at the middle and thick at the edges. Clear? Yes. Next concept is about image formation in the eye. Image formation in the eye. Then splitting of white light. And then dispersion of white light. So let us learn about all these things in detail. Light and associated phenomena. Okay. So light, as you all know, light is a form of energy. Light is a form of energy. It enables us to see things around us. It enables us to see things around us. Light always travel in a straight line. Light always travel in a straight line. It is known as rectilinear propagation of light. So the way it travels, straight line, it's said to be as rectilinear propagation of light. Clear, children? Yes. Next, due to this property, shadows are formed when light faces any obstruction. Due to this property, shadows are formed. Clear? Then, reflection of light. The first concept here is about reflection. Reflection of light. So what do you mean by reflection? When light falls on an object. When light falls on an object, it changes its direction and bounces back. So when light falls on an object, it first receives and then it changes its direction and it bounces back. Clear? This bouncing back of light from the surface is known as reflection of light. I repeat, bouncing back of light from the surface is known as reflection of light. Clear, children? Yes. Now again, this reflection is further classified into two types. What are they? Regular reflection and irregular reflection. What I said? Regular reflection and irregular reflection. Okay, so first let us learn about regular or specular reflection. Specular reflection. So what is this? It is a reflection that takes place from a smooth and shiny surface. Where? From a smooth and shiny surface. All the parallel beam of light falling on this surface is reflected back in one other direction. Clear, children? Yes. The rays of light remain parallel even after reflection. So even after reflection, rays of light will be parallel. Such type of reflection is called as regular reflection. What is that? Regular reflection. So the main thing is it takes place from a smooth and shiny surface. Now I just want to tell about example. Example for regular reflection is plane mirror, polished metals and water which have smooth surfaces. Plane mirror, polished metals and water which have smooth surfaces, so that the reflection from their surfaces is regular reflection. Clear, children? Yes. Now let us learn about the second type, that is irregular or diffuse reflection. What is that? Irregular or diffuse reflection. So here this type of reflection will take place through a rough and dull surface. Where? Rough and dull surface. It is a reflection that takes place through a rough and a dull surface. That is what? Irregular reflection. Now the rays of light do not remain parallel after reflection from the surface. Make a note, children. In irregular, the rays of light which is coming from that surface will not fall in a parallel way. Do not remain parallel after reflection. Whereas in regular, it will remain parallel. But here in irregular, it do not remain parallel. Clear? After reflection from the surface, then they scatter in different direction. The light which is getting reflected will scatter in different direction, not in a same direction, different directions. Such type of reflection in which a parallel rays of incident light which do not remain parallel after reflection is called irregular or diffuse reflection. What I said? Irregular or diffuse reflection. So about irregular, two things are important. First, it takes place through rough and dull surface, whereas there in regular, smooth and shiny surface, is it not? But here in rough and dull surface. Second point is, it do not remain parallel. Which one? The rays of light will do not remain parallel, but there it remain. There in sense, in smooth, it will remain parallel. Clear? That's what about irregular diffuse reflection. Clear? Yes. For example, the surface of wall and tree are rough or uneven, so that the reflection from their surface is example for irregular reflection. Clear? So for example, they have mentioned about wall and tree. They are rough and they are uneven. Clear, children? Yes. Then let us learn about some important terms in this reflection. See, you can see a picture here. So this picture denotes plane mirror. What is that? Plane mirror. Now light is falling on this direction to the point Q. It is a plane mirror here. So when light falls on this direction, a ray of light always travel in a straight line, is it not? So when it travels here, this ray of light is said to be as incident ray. Incident ray. I-N-C-I-D-E-N-T. Clear? Yes. Then what happens? It reaches the point Q and then the plane mirror, and then it will reflect back. It will reflect back. So then light passes in this direction, whereas it is said to be as reflected ray. What is that? Reflected ray. Now here the centered line is normal. Is said to be as N or normal. Then there is two angle. This side the angle is, that is QR. This angle is called as angle of reflection. What is that? Angle of reflection. And this side, it's said to be as, is called as angle of incidence. What is that? Angle of incidence. Now here, where the light touches the plane mirror, that point is said to be as point of incidence. The point is called as point of incidence. Clear, children? So now let us learn about some important terms in this. First thing about reflecting surface. What is that? Reflecting surface. The side of the mirror that reflects light and forms images. The side of the mirror has two sides, is it not? So the side of the mirror that reflects the light is said to be as, is called as reflecting surface. Is called as reflecting surface. Whereas the other side of the mirror is called as non-reflecting surface. Non-reflecting surface. Clear, children? Yes. Now next thing about incident ray. Incident ray. What do you mean by incident ray? The ray of light that falls on the surface of reflecting material or the mirror is called as incident ray. I repeat, the ray of light that falls on the surface wherever it receives the light. The ray of light that falls on the surface of the reflecting material or else the mirror is called as incident ray. Clear, children? Yes. Next, reflected ray. What do you mean by reflected ray? The ray of light that is sent back from the surface of the reflecting surface. So once it receives, again it will reflect. The light will get reflect, is it not? So that is also passed through a straight line, and that ray of light is said to be is called as reflected ray. That's what, a ray of light that is sent back from the surface of the reflecting surface is called as reflected ray. Can you understand? Yes. Next thing is about point of incidence. What is that? Point of incidence. The point at which the light ray strikes the reflecting surface. The point at which the light ray, the light what it receives, no, from the source, from the main source. So when it receives, that point strikes the reflecting surface. That point is said to be as point of incidence. I repeat, point of incidence, the point at which the light ray strikes the reflecting surface is the point of incidence. Clear, children? Yes. Next thing is about normal. I said in the middle you can see a dotted line which is passed to a straight line. That's what? Normal. So what do you mean by normal? The perpendicular line drawn from the point of incidence, where from the point of incidence of the reflecting surface is normal. So from the point of incidence, the perpendicular line which is drawn from the point of incidence is called as normal. Of the reflecting surface is called as normal. Clear? Next is about angle of incidence. What do you mean by angle of incidence? The angle formed between the incident ray and the normal. Incident ray where we receive the light, is it not? And the normal is the middle line. So the angle formed between the incident ray and the normal is the angle of incidence. What is that? Angle of incidence. It is denoted by angle symbol and I, the letter I with the angle symbol. Okay, so that is what about angle of incidence. Now about angle of reflection. Angle of reflection. What is that? The angle formed between the reflected ray QR. Here Q and here R. QR. The angle formed between the reflected ray QR and normal QN. And normal QN. Okay. So here that is called as angle of reflection. What is that? Angle of reflection. It is denoted by angle R. Angle R. Clear? Yes. Next concept is about laws of reflection. Laws of reflection. There are two laws of reflection. There are two laws of reflection. Okay. So what are they? First law is about the incident ray, the reflected ray and the normal. What and all I said? The incident ray, the reflected ray and the normal. All the three. Okay. The normal lie at the, I repeat, the incident ray, the reflected ray and the normal at the point of incidence. At the point of incidence here, the touching point is called as point of incidence, is it not? At the point of incidence, all lie on the same plane, the flat surface, all lie on the same plane. That is the first law. Okay. Second law is about the angle of incidence is always equal to the angle of reflection. The angle of incidence here is always equal to angle of reflection. That is, angle I is equal to angle R. Clear, children? Yes. So this is what about laws of reflection. Now, spherical or curved mirrors. What is that? Spherical or curved mirror. A mirror whose reflecting surface curves outwards is called as convex mirror. I repeat, a mirror whose reflecting surface curves outwards is called as convex mirror. Then a mirror whose reflecting surface curves inward is called as concave mirror. Now, for example, a spoon. You can see a spoon. Is that not? Yes. Now, the outer surface of the spoon. The outer surface of the spoon acts like a convex lens. Convex in sense, thick at the middle and thin at the edges. Now, the inner surface of the spoon. Whereas it acts like a concave mirror. The inner surface of the spoon acts like a concave. How it will be? Thin at the middle and thick at the edges. Yes, children. Now you can see the picture for types of curved mirror. So here they have given two sphere. Is it not? Yes. Here this is about concave mirror and this is about convex mirror. So what do you mean by concave? Thin at the middle and thick at the edges. Is it not? Thin at the middle and thick at the edges. And convex, thick at the middle and thin at the edges. So now here they have given a point C. Is it not? In both the sphere they have marked a point C. What is that C? C denotes center of curvature. What is this? This C is the center of sphere of which the mirror is a part. Next thing, principal axis. You can see in both the side, principal axis. What is this? It is the line passing through the center of curvature and the pole. So here you can see pole also. Is it not? Yes. Then next thing, radius of curvature. They have marked an arrow mark. Is it not? Radius of curvature. What is this? It is a radius of sphere. You all know from the center, wherever you are having like this, that is considered to be as radius. Is it not? Yes. It is a radius of sphere of which the mirror forms a part. Then next thing, principal focus. What they said? Principal focus. What is that? It is a point at which all the rays meet or appear to diverge after reflecting from the curved surface of the spherical mirror. I repeat, principal focus. It is a point at which all the rays meet or appear to diverge after reflecting from the curved surface of the spherical mirror. Clear, children? Yes. Now let us learn the same, that is pole. First important term, pole. What is pole? It is the geometrical center of the mirror. Next thing is about center of curvature. What is this? It is the center of sphere. Of which the mirror is a part. Next thing is about principal axis. Principal axis. It is the line passing through the center of curvature and the pole. Center of curvature and the pole. Clear? Next thing is about radius of curvature. Radius of curvature. It is the radius of sphere of which the mirror forms a part. Next thing is about principal focus. Principal focus. It is a point at which all the rays meet or appear to diverge after reflecting from the curved surface of the spherical mirror. Clear, children? Yes. Now let us learn about concave mirror. Okay, so you can see the picture for concave mirror. Here some lines. This is the plane mirror, and here the focus, and here the rays of light are passing. Okay, and now let us learn about this. The concave mirror reflects the parallel rays of light in such a way. The concave mirror reflects the parallel rays of light in such a way that after reflection, all the rays of light meet at one point. All the rays of light meet at one point. Okay, so this is called focus. This F is called focus. The focus of concave mirror is in the form of mirror. The focus of concave mirror is in the form of mirror. Then the focus of concave mirror is real. Clear? Because light rays actually passes through it. That is real because light rays actually passes through it. Since a concave mirror converges a beam of parallel rays, what it will do? Here it is converging. All the parallel rays get converged at one point. Is it not? That's what. Since a concave mirror converges a beam of parallel rays, a concave mirror is also known as converging mirror. What is that? Converging mirror. Clear? So here the distance between the focus and here the plane mirror is said to be here as focal length. Focal length. Now let us continue with convex mirror. What is this? Convex mirror. The convex mirror reflects the reflected rays of light, in such a way that after reflection they will spread out. What it will do? That will spread out. You can see here the convex mirror. Okay, so rays of light is passing from this direction to this direction, then this is getting reflected. This arrow mark denotes the reflected rays. Okay, here these are reflected rays. Then that after reflection they will spread out the rays of light which are diverging. How it will be? Which are diverging. Okay, it won't converge, it will diverge. The parallel rays of light appear to diverge from a point. The parallel rays of light, these are parallel rays. Okay, so this light appears to diverge from a point which is present behind the mirror. Where is it? Behind the mirror. This point here, you can see that angle of extension here, is it not? Yes. So this is what about focus. The parallel rays of light appear to diverge from a point which is present behind the mirror. This point is called the focus. This point is called the focus. The focus of convex mirror is virtual. How it will be? It is virtual. What do you mean by the word virtual? It's not exact real, it's almost similar. Okay. The focus of convex mirror is virtual because light rays do not actually pass through it. It does not actually pass through it. Here it has been extended, the angle, and this point is said to be as focus. Is it not? Since a convex mirror diverges a parallel beam of light, since a convex mirror diverges a parallel beam of light, it is also said to be as, it is also known as diverging mirror. What I said? Since a convex mirror diverges a parallel beam of light, it is also known as diverging mirror. Diverging mirror. Clear? Now, let us learn about the uses. Uses of curved mirrors. Uses of curved mirrors. So, spherical or curved mirrors have various applications in our daily life. So, first let us learn about concave mirror. Concave mirror. Where we are using this? They are used by dentists. They are used by dentists to see the magnified image of teeth. To see the magnified image of teeth. Then, this concave mirror is also used as magnifiers. Where they are used as magnifiers in movie projectors. Where? In movie projectors. Now, let us learn about one more point about the uses of concave mirror. They are also used in headlights of cars and in flashlight and in torch. They are used as reflectors. Clear? Next is about convex mirror. We are going to learn about the uses of convex mirrors. What is that? They are used as rear view mirrors. What is that? They are used as rear view mirrors and side mirrors. Where they are used in vehicles. What for? They are used for seeing as much of road and approaching vehicles as possible. Clear? Then they are used as reflectors. These convex mirrors are also used as reflectors. Where they are used in street light which diverge the reflected light. They are used in street light. What it will do? Which diverge the reflected light in all direction and illuminate a large area around it. Then they are used in modern railway station. This convex mirror is also used in modern railway station or in metro station. To have a full view of trains. Clear? Next thing is about refraction. What do you mean by refraction? Refraction is a phenomenon which occurs when a ray of light passes from one transparent medium to another. What happens here? Ray of light passes from one transparent medium to another. Okay. Then, for example, the spoon. You know about the spoon, is it not? The spoon appears to be bent. How it will be? Appears to be bent when it is kept in a glass of water. Where it will be bent? When it is kept in a glass of water. Is it not? Another example, coin also we can tell. Coin. Okay, coin, it's when it is kept in the water. How it will be? When it is kept in the water, when we are noticing it from outside, it appears to be raised off. So that is also one more example. Then it is important that both the media have different densities. How it will be? Both the media have different densities. When a ray of light passes from one transparent medium to another transparent medium, there is a change in its direction. There is a change in its direction. So, when light usually travels a ray of light, when it has passed from one transparent medium to another transparent medium, there is a change in its direction. Let us learn about this. For example, the speed of light. The speed of light in vacuum is 3 into 10 power 8 meter per second. How much? 3 into 10 power 8 meter per second. Whereas in glass it is 2 into 10 power 8 meter per second. So light travels through glass in the speed of 2 into 10 power 8, and in vacuum it travels the speed of 3 into 10 power 8 meter per second. So which one takes more time? Light takes more time. Light takes more time to travel in glass. Is it not? Light takes more time. Light takes more time to travel in glass than it would have taken in vacuum. Thus, light changes its direction. Light changes its direction while traveling through different medium. Is that clear to everybody? Here, 3 into 10 power 8. Okay, for example, you just have in short 3 into 10 power 2, that is 300 meter per second. 2 into 10 power 2, that is 200 meter per second. So 300 is bigger or 200 is bigger? 300, is it not? So when the light is traveling through glass, it takes more time, is it not? That's what. So thus light changes its direction while traveling through different medium. Clear, children? Yes. Then here, when light travels from a rarer to denser medium, two mediums, is it not? They are having different densities. So here, when light travels from a rarer to denser medium, how it will be? It bends towards the normal. It bends towards the normal. Then when light travels from a denser to rarer medium, where from denser to rarer medium, then it bends away from the normal. It bends away from the normal. Then when light travel along the normal, there is no deviation. There is no deviation. That is, ray has no refraction. Ray has no refraction. This is what about convex mirrors, and then about refraction. Clear? Next thing is about lenses. What is that? Lenses. So what do you mean by lenses? It can be defined as a transparent medium. Lens can be defined as a transparent medium having one flat and one curved surface. It may be in two ways. One way is it may have one flat and other surface is curved surface, or else both the curved surface, both the side it will be curved surface. So this is what about lenses. Lenses can be defined as a transparent medium. It can be defined as a transparent medium having one flat and one curved surface, or both the curved surface. Both the side they have curved surface. Now let us learn about lenses that are made up of two curved surface. They are made up of two curved surface. They are basically two types, that is convex and concave. Convex and concave. So first let us learn about convex. So this is a picture for convex and this is for concave. So convex means always you should remember that in the center it will be thick and in the edges it will be thin. thick at the middle and thin at the edges. That's what convex. And about concave, here it will be thin at the middle it will be thin, and at the corner it will be thick. Thin at middle and thicker at edges. So convex, a convex or converging lens. Convex lens or converging lens is thick at the middle and thin at the edges. How it will be? Thick at the middle and thin at the edges. It can be made by joining a curved surface. It can be made by joining a curved surface. It usually magnifies images. Next thing is about concave. What I said? Concave. And concave is also known as diverging lens. What is that? Concave is also known as diverging lens. A concave or diverging lens is thin at the middle. How it will be? Thin at the middle and thicker at edges. Objects look smaller through concave lenses. It looks smaller through concave lenses. So now let us learn about some important terms in this. So first about principal axis. What is this? Principal axis. The line joining the centers of two spheres from which the lens is formed. What is principal axis? The line joining the center. The line joining the center of two spheres from which the lens is formed is called the principal axis. Now about optical center. So in a sphere, the center of the two sphere is said to be as principal axis. Now about optical center. The center of the lens is called the optical center of the lens, which is denoted by letter O. I repeat, the center of the lens is called the optical center of lens, which is denoted by letter O. Next thing is about principal focus. What I said? Principal focus. A point at which parallel rays of light converge. Converge after passing the lens is said to be as principal focus. A point at which parallel rays of light converge after passing through the lens. It converges at here. Okay, so this is what said to be as principal focus. Next thing is about focal length. What is that? Focal length. Focal length is the distance between the optical center and the focus of lens. It is a distance between the optical center and the focus of lens. So here, the thicker the lens, the more it bends the rays. The thicker the lens, the more it bends the rays. And the smaller is the focal length. You can see the picture here. So this is what about convex lens. What I said? Convex lens. So here, what happens? Light is passing through the convex lens. Light is passing through a beam of light parallel. Then, so it converges together here. That is said to be as focus, and the distance between the focus and the center is said to be as focal length. What I said? This is between the optical center and the focus of the lens. Optical center and the focus of the lens is said to be as focal length. Then about concave lens. You can see the shape of the concave lens here. Okay, and here light is passing in this direction, and then what happens? It focus here. Okay, so here then when it receives this light, automatically it gets diverges here. It diverges from this point. Okay, and then this distance from the optical center and the point of focus is said to be as is called as focal length. It's called as focal length. Clear, children? Yes. Yes, children. Now you can see a lighted candle and a convex lens. Okay, so you can see the real image. So till one distance, the image of the object will be real through convex lens. That distance is said to be as focal length. Now, if the lens is moved little more, then you can see a large and blurred image of the object. Is it not? Yes. Then, if you are moving little more further, you can see a flipped, an inverted image of the candle. Can you all see? Yes. This is the flipped image. So, through convex, you can see three types, that is small, real, and then large and blurred, and then an inverted image. Yes, children, now an activity for you all. What you are going to do? You are going to stand in front of the mirror and observe. Stand in front of the mirror and observe. How it will be? Your left side seems to be right and right side seems to be left. Is it not? Yes. So, whatever you are doing in the left side, that will be visible on the right side. Is it not? That image is called as laterally inverted image. What is that? Laterally inverted image. Clear? Then, write a word. For example, ambulance, and read the letters in the mirror. Read the letters in the mirror and just note it down. However you observe in the mirror, note the same words, same letters in the mirror and just forward in your class email ID. Clear? So here for an example I gave ambulance. You just write any word and just read it in the mirror. Okay, so the image, what you cannot capture, the left side comes on the right and the right side comes on the left is said to be is known as virtual image. Okay, that image is said to be as virtual image. So just take a virtual image of any word and just write the letters however you are noticing in the mirror and then forward in your class email ID. This is your activity. Clear, children? With this, we have come to an end of this chapter. So after watching the video, read the lesson thoroughly so that you can understand well. Thank you all. Thank you, students.